Alright, I'm starting up the stream. Looks like the stream's running. Hi everyone, I'm TigerHawk3, and today we're going to do a little more with the Python Deque implementation, because last time I mentioned that we fixed the string and repro methods to handle recursion. So if you have a Deque and you then append a reference to itself to it, it handled that. But what if you had Deque containing a reference to Deque B and Deque B containing a reference to Deque A? Then it didn't work anymore, because it was just checking whether an item in it was the same as itself. Whereas if you had Deque A containing Deque B containing Deque A, then you would say, well, we're in Deque A, and that has a Deque B in it. That's fine. That's not the same one. And then you would go into that and see Deque A, and Deque A isn't the same as Deque B, so that's fine. And then Deque B isn't the same as Deque A, and so on forever. 1,000 times, actually. If you have the recursion limit set to the default, which you can change if you think you really need to with sys.set recursion limit, sys.recursion limit, something. It's not recommended to change it, because it generally means you're doing something wrong if you need more than that, usually. Anyway, so I solved that with a set. And what I mean by solve it with the set is I mean I'm going to keep track of each object that I've seen when creating the string or repro of a Deque. I'm going to keep track of each object that I've seen, and if I have seen it, then I'm going to put a static representation of, you know, Deque with ... So, first thing I had to change was we're going to add the set as a class variable, not an instance variable, class variable. That means there's one of these, and it is shared between all instances. So if you had Deque A, or let's just say A equals Deque, and then B equals Deque, you could do A.scene.add 0, and then you could say B.scene, and you would see 0 in there. So anytime one instance does something with a class variable, it happens in all the others because there's only one. So what do I do next? In string and repro, I think, is where I do stuff. And then there's some other things. Okay, let's do that first. String and repro. Okay. So here is one thing that I had to change. This isn't sent explicitly when, or I should say, when you call string implicitly by saying str with no underscores around it, and then passing the string built-in function your object, or as happens when you send something to print, that calls, you know, this method, but it's not going to send this. So that's going to have a default value of true if you just call it without specifying anything, and that means it's basically the top level. So we're going to start there, and so if it's the top level, then we will, this self.class means the class itself, and this is so we don't have to say Deque, because then we would have to change it throughout if we ever decide to change the name of the class. So it's our class variable, scene, this is our set, and we're going to add the ID of this Deque itself. So when we add the ID, we're not adding this Deque itself, because this Deque isn't hashable, it's mutable, it wouldn't make sense to to have it hashable, but its ID is just an integer. So we can add the ID of this object to what's been seen, and that will let us keep track of whether we need to print it again if it shows up again. And so, yes, this is one line, one logical line, technically. It's 3 physical lines, but one logical line. You can see the difference between those, like in the interactive interpreter. Once you finish a logical line, the interpreter will wait for you to finish it, even if it's not on a physical line. So if you write an opening parenthesis and then press enter, it will give you a dot 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 because there's more, and it won't finish that logical line until you have the ending closing parenthesis. And then it will say that's one logical line, and it can span multiple physical lines. That's fine. You can also indicate that you want to end a physical line without ending the logical line by having a backslash at the end, but it's preferred to use implicit line continuation, which means having parentheses or braces or whatever structure you have. So we're going to have Deque at the outside, and then parentheses, and brackets, because that's how you create a deck. And so we'll have this. That's going to be formatted with the content of this whole thing. And this whole thing is, I know it's very large, it's a thing, but we're going to join on a comma and a space, basically the repro of every item in this deck. For item and self, we're just going through self, and so we have, this is kind of longish, so we have something, this or that, else. Where's the if? Oh, here we are. We have a static representation of a deck that will indicate it's recurring. So we'll put this in if this condition is true, which we'll get to afterward. Otherwise, we will have, we will just get the repro of the item. Oh, I extended that ternary, didn't I? This, if, that, else. This, if, that, else, whatever. Okay. So first I check if this object is an instance of a deck. If is instance item type self, you could also more or less say this with if type item equals class Deque or whatever, or type item is equal to type self. So it's just checking if this item is a deck, and so if it is a deck, we're also going to check if the ID of this deck that we have, that we're looking at, is in the set of things we've seen. If it's not, then we will add it, and this returns none. So a falsy thing or a falsy thing will result in false. And so if this ends up false, that we haven't seen it, a little lost. Probably too many lines. Too many physical lines in one line. This is how many characters? 275. About 250 non-indentation characters. This is probably too much. Anyway, So we have if it's a deck and we've seen it, or we will add it now, then we just have this. Otherwise, so if we have a deck and we've seen it, this only evaluates to true if we have seen it. Because if the item's ID, I should say, is in the class seen set, then we won't need to look at the OR and we won't need to add it again. And this will just be truthy, so we'll have truthy and truthy. So we'll have just, static representation. It's a deck and we've seen it. So we don't need to reproduce it again. But if it's a deck and we haven't seen it, because we need an AND, it's a deck and hadn't seen it, or, and this also will return a falsy value. So if it's a deck and we haven't seen it yet, then we might want the repro of the item. But if it's a deck that we merely haven't seen yet, then we want to say that this particular one is not a parent. It's not the top level deck. So we say, instead of just, repro item, we have to say item dot and explicitly call it and send it false if this item is a deck again. So if it's a deck, if we've seen it, we just write this. Otherwise, we add it. And then if it's a deck that we haven't seen before, then we have the repro of the item and say it's not the parent. And if it's not a deck at all, then we just use the repro of the item without any special anything. And after we've created that, we have to clear out this set of scene IDs, and that will make it ready for the next time it is called. So that's how to avoid infinite mutual recursion. You keep track of what you've seen and what you haven't. And by the way, don't code like this. Don't have a logical line that's 250 characters long. It's generally bad. But I just wanted to keep the join here, and I figured I could, just do it, and it works. So, but don't do that. Clear it out, return the result. Yes, okay. For a while I had a little bug where I was just, instead of result equals saving it, I was just saying return still. So I had return this expression, because that's what I had before. And then it wasn't clearing out the set of scene items afterward for some reason, because I had already returned. I'm like, oh yeah. So I save it, and then I say after we've created that, we clear out the set and return the result. Repro is, instead of just str and of self, then we want self, and we explicitly call this magic method, and we send whatever the parent value is, which just preserves what was sent in. So if it's the first one that was just called regularly, then it will be parent equals true, and then it will pass parent equals true, and we'll do that. Great. Okay. What else? What else? Starting at 770, 792, a whole bunch of that. It's kind of important. Actual bug. So in this stuff, the augmented assignment things when you have a plus equal or times equal or whatever. You can do whatever logic you want. You can make whatever you want to happen, and then after that, whatever that method returns is assigned to the variable that you're augmenting. If you have x plus equals something, it calls this method for x and then assigns that return value to x. So I was doing this, right? We went over this. We look at the node and the value because we zip the nodes in the deck with the elements of whatever we're looking at, and we just, do that operation. Add is the plus, so I add is plus equal, and we just do this element plus equal the value. And that doesn't change the reference for self for the deck. It just does it in place, and that's the vector addition rather than concatenation. So had to add this line, return self, because if you don't, it'll end up returning none. And then you just have none everywhere. If you had, my instance of a deck plus equal some list of integers or whatever, then you would have my instance of a deck would then be none. So that was wrong, so I had to return self. I just literally added return self in all of these augmented assignment things, and then they will actually do what they're supposed to. Let's see. Technically this sort of worked if you had my deck equals, something, and then x equals my deck. You could then do x plus equal, a list of some kind, and then x would then be none, but my deck would still be the original deck that you created, because that would just be assigning none to the x label. But the deck would be unaffected, it would still be there, it would have gone through all that logic to do the element-wise addition, and then you would have that. But this, you're not supposed to have to save a reference to it because it gets thrown away. That's wrong. So return self, and then it works, and I don't think there's anything else. So how long is this? 1,135 lines. I think a lot of it is doc strings. Don't I have I was pretty sure. Okay, I thought I had a little regular expression to find doc strings so I could see how much of it was comments. A substantial amount of this is just comments. See? Lots of comments. There's some blocks of stuff that isn't comments, but not very often. This is the entire matrix multiplication code. Does it fit in one screen? No. It really doesn't. This is kind of part of it too, this find row, because that's for the multiprocessing IMAP. Anyway, so today we fixed augmented assignment, and we solved the problem of mutual recursion in, this context, not entirely for everything forever. But, oh, if you have, if you're doing vector operations which have mutual recursion, this does not handle it. It only does it for the string and repro methods, because if you had two decks, A and B, and A was 1 to A, and B was 3, 4B, and you did A plus B, you would have a new deck with 1 plus 3, and then that's 3, and 2 plus 4 is 6, so you'd have 3, 6, and then you would have A and B. And A plus B is 1 plus 2, sorry, 1 plus 3, 2 plus 4, and A plus B. And then, and so on and so forth forever, and I don't even know what it should look like. So, DQ dot dot dot, that's not a useful thing. It's useful if you want to see what's in it, because then you'd see, oh, there's, you know, some kind of recursion there. But if you're doing a vector operation, then having like a bunch of integers, for example, and then you have a string that says, you know, we encountered mutual recursion, basically, that's not a useful thing. It should be a failing error. By the way, Python built-in types and standard library types, as far as I've seen, all properly handle both self-recursion and mutual recursion. If you have two lists, A and B, and they contain the other, prints fine. Same for tuples, dictionaries, collections.deque, and now deque.deque. So, probably not the tidiest solution, but the general idea is good. I only needed like 2 lines, right? No, I needed a bit more than 2 lines, because I had to create the set in the class, and then this is another line, but I also needed this thing and that thing and this. 1, 2, 3, 4, 5, 6, 7 lines. 7 lines, and one of them is gigantic. Would have been tidier if I'd done this, you know, the Pythonic way, instead of a whole bunch of nested ternary if-elses. But that's okay. Sort of. You know what I mean. It's clear from, you know, what you see. It's obvious what it does and why and how. Anyway, that's all for today. Just wanted to show that little change. Now I really don't know what else to add or change in this Deque implementation, because it seems complete. Self-recursion, mutual recursion. I don't know. As far as I can tell right now, it is complete, which is pretty cool. You can see the code and the commits in the small scripts repo linked in the description, and in the Deque repo linked in the description. And the Deque repo also has a README that will display when you go to the repo's main page, and it will show you how it works, explains all the methods, etc. Mostly it says it's similar to collections.deque, but with a few differences, and here they are, and then explains the differences, and that's it. But yeah, thanks for watching. I will see you next time. Not sure what it's going to be, but something, I guess, at some point. So, have a good one.